Okie dokie, here is a quick video on stopping distances. And this is all to do with reaction times and the effects that they have on stopping a car, but also the physical factors that affect stopping a car. So we're going to have ourselves a little car here. There he is. And I'm also going to have the driver of the car with his lovely little brain. We'll have that here with his eyeball there, nerve up to the eyeball, and then nerve all the way down to his foot. Okay, so let's have a look at stopping distances. Stopping distances are basically, as you'll see, are going to be made up of two things. They're going to be made up of something called the thinking distance and the braking distance. Added both of those together and you get the stopping distance. And what it is, it's the distance it takes a car to come to a stop. So this is something that actually comes up in driving theory tests, which you guys will be taking in a few years' time. That won't go. Right, here we go. Let's have a quick look then. So I've got a car and it's driving along here. And let's just say, out of the blue pops a little person. There's my little person. So my car's driving along here, let's say 30 miles an hour. And all of a sudden, out pops a little person. In that time, your eyes notice the change in the environment. In biology, you call this a stimulus. It's basically a change in light or a change in something in the environment. And then your eyeball notices that and sends a signal up to the brain. That there then sends a little signal and goes, oh, there's a little person. I better send a signal down to my foot to tell it to brake. And press the brake. Now this is essentially takes the same time as your reaction time, which is around 0.2 of a second, a fifth of a second. You've done reaction times in biology and physics and all through school. So we know that time for the signal to get from the eye to the brain back down to the foot would take about 0.2 of a second. In that time, so this car got to here before the little kiddie came out into the road, it is still travelling. Because in that time the car is still travelling, nothing has changed about the car because the signal has only now just got down to the foot. So we can actually work out that if that was travelling at 30 metres per second and we have a reaction time of 0.2, we can work out, because speed v equals distance s divided by time, rearrange that, and v times time equals the distance. 30 metres per second times 0.2 equals 0.6. 6 metres. So we know that actually before anything happens, before the brake's pressed, the car actually has already travelled 6 metres closer to the little person who's jumped out. That there is your thinking distance. The distance travelled between seeing the stimulus and pressing the brake. Thinking distance. Bear in mind, in your answer, I've said nothing about reaction time. The thinking distance is the distance travelled between seeing the stimulus and pressing the brake with your foot. You've then got all the time it takes for the car to come to a stop. And luckily he stops just before. Did you notice how good the sound effects were, by the way? I think they were good too. Now, that depends on the speed. It depends on the amount of kinetic energy within that, because a bit of revision. Kinetic energy equals half times mass times speed squared. If it's got kinetic energy, we've got to get rid of that kinetic energy, and the brakes have to do work against it, and work done is force times distance. So look at all these things in our physics equation that could affect the speed of the car and how hard it is to stop. The mass of the car, if it's a heavy car, there's a lot of energy, so there's a lot to stop. The force that the brakes can apply, how good are your brakes? Can they apply a great force? And if they can, then we'll stop sooner. Also, what about the road surface? Is it rainy? Is it icy? And so on. So all these factors could affect it. So you then get into the final bit of stopping distance, which is what are the factors that affect thinking distance and braking distance. Like we just said, speed affects this. Speed also affects the thinking distance too. The mass of the car would affect how long it takes, the distance travelled before it comes to a stop, between pressing the brake and stopping. The road conditions, brake quality, and the tyres. What affects thinking distance? Well, thinking distance, like we said, is the distance it takes to between seeing the stimulus and coming to a stop. So what would get in the way of that signal travelling up to the brain and down to the foot? Well, it's things like drugs, alcohol, tiredness, anything that means that you would travel a longer distance between seeing the stimulus and pressing the brake. And final thing, the braking distance, just remember, is the distance travelled after pressing the brake to come into a stop. Okay, right, now come up with a little poster and a little challenges to think of all the things that we have to around the country in terms of driving laws, things to help us that would affect stopping distance and allow us to have safer roads. What would allow smaller stopping distances? What do we have around the country? So think about the laws, think about signs, think about everything. Pop it in a poster, only take 10-15 minutes, and stick that onto Firefly for me.